Welcome back, everyone. Now let's begin discussing lists in Python. Lists are ordered sequences that can hold a variety of object types, and they use square brackets and commas to separate the objects in the list. For example, here we can see a list of numbers 1, 2, 3, 4, 5. And lists, just like strings, support indexing and slicing. And lists can also be nested and have a variety of useful methods that can be called off of them. Let's explore all these concepts in a Jupyter Notebook. Let's begin by defining a variable called myList, and we'll set it equal to the numbers 1, 2, 3. So here we can see that a list is defined by these square brackets, and then we have every object type separated by a comma. We just created a list of integers, but we could have also created a list of mixed object types. So the first one could have been a string, the second one could have been a number or a floating point, and this list has no problem. So we can see Python lists are very flexible in the data types they can hold. And if we ever want to check the length of a list, just like we could check the length of a string, we just use the len function that's built into Python and then pass in myList, and it returns back how many elements or items are in that list. So here we have 3 items, string 123.2. Now, just like a string, because a list is an ordered sequence of elements, we can use indexing and slicing. And this works just like a string. So let's show you what I mean by that. I'll say my list is equal to, let's say 1, 2, 3, run that. And then if I wanted to grab the element at index 0, so that's the very first element, I would just say my list 0, run that, and I get back 1. And if I wanted to grab everything starting at index 1 all the way to the end, well, it's just like string indexing and string slicing. I would say, hey, start at index 1, colon, go all the way to the end, and then we have 2 and 3. So this slicing and indexing works just like a string, and you can also concatenate lists together. So let's see this right here. I have my list right now, which is 1, 2, 3. I'm going to create another list, which is equal to, let's say 4, 5, and I can say my list plus another list, and it will concatenate to a new list, 1, 2, 3, 4, 5. Notice here, I'm not actually saving this result, so if I were to call back my list or another list, I can use tab autocomplete here, I still have those 2 separate lists. If I actually want to save this, I need to assign it to something. So we can say new list is equal to my list plus another list, and then if I check out new list, now it's 1, 2, 3, 4, 5. Okay, so those are the basics of lists. So notice right here we have the indexing, slicing, and concatenation. That should feel pretty similar to a string, except what's different than a string here is that we can actually mutate or change around the list. Remember back when we were trying to change letters around in a string, it wouldn't let us. A list has no problem in that manner. So if I check out my new list, it's 1, 2, 3, 4, 5. Let's go ahead and change one of these elements. Let's change 1 to be in all caps. What I could do is say new list at position 0 is now equal to 1 in all caps. Now let's make it really obvious that we're changing it. So I'm going to say 1 all caps. And now if I take a look at my new list, I have 1 all caps, 2, 3, 4, 5. So that's a way you can actually mutate or change the elements that are already in a list. And that's something that differentiates it from a string, besides the fact that it's also holding different element types in braces and commas. So again, strings, you can change them and affect elements inside of them. Another common operation that you may want to perform is to add an element to the very end of a list. And the way we can do that is we say new list dot and hit tab here, and you should see all the various methods that are available to you in a list. The one we're going to show here is the append method. An append allows you to append a new item to the end of a list. So we'll say append 6. And after running this, what we're going to see is that if I check out my new list, I have 1 all caps, 2, 3, 4, 5, and I have 6 now. So notice how append does actually affect the list, and we call this affecting it in place because it permanently changes that new list. to have an element at the end of this. So this is known as append, and again, it allows you to place any item at the end of a list. Let's try it one more time. We'll say new list, append, let's say 7, run that, and let's check our new list, and I can see 1 all caps, 2, 3, 4, 5, 6, and then 7. Just because I'm very zoomed in here, it's kind of cutting it off, but if you were to zoom out, you'd start seeing it in a more normal fashion. All right, so we know how to add things onto a list. Let's talk about removing items from a list. To do that, we can use the pop method. So pop is actually going to pop off an item from the end of a list. Let's show you what we mean by that. We're going to say new list dot pop, open and close parentheses. Remember, for a lot of these method calls, if you don't have parentheses there and you just run them, it's going to report back, hey, that's the pop function inside of this new list object. If you actually want to call it, then you need open and close parentheses. And later on, we'll discuss the differences between methods and functions. You've probably heard me use those terms a little bit interchangeably right now. We'll go into a lot more detail about them later on. But right now, we saw that we said new list.pop, and it's popped off the 7, and it's actually returned it as well. And if we take a look at what new list is now, it no longer has the string 7 in it. Now it just goes up to the string 6. So let's actually save the result of a pop. So we can say popped item is equal to new list, and I'm going to say dot pop, and when I run this, what's going to happen is this popped item is now the item that was at the end of that list. So I can copy and paste this, popped item, and now I have 6 saved as the pop item, and it's no longer as part of my list. Now, a common question that arises here is, hey, I don't want to remove something from the end of the list. I want to remove it at a specific index. For instance, I want to remove the 1 all caps at index 0. Well, it's actually no problem. You can pass in an index position into the pop. We can say new list dot pop, and then just pass in the index position of what you want to remove. We can see here that 1 all caps is at index position 0. So let's pass in 0 there, run it, and we can see that we've popped off 1 all caps. And if we see new list now, we have 2, 3, 4, 5. So again, pop basically removes items from the list at whatever index location you provide. By default, the index location is -1, the very end of a list. So reverse indexing also works with a list, just like it worked with a string. A few more methods that I want to discuss besides pop and append, which are going to be really common methods you're using, is sort and reverse. So to do this, I'm going to create a new list. Let's zoom in here. Or I'll redefine new list. And I'm going to redefine new list to be a couple of letters here, but we're going to have them sorted out of alphabetical order. There we go. And we'll also make a numbers list. So we'll say num list is equal to, and let's make this just a bunch of numbers out of order as well. Okay, so we have 2 lists. If we ever want to sort these lists, what we can do is call the sort method off of them. We can say new list, sort, and you can use tab autocomplete to do this, open and close parentheses, and this is actually kind of a special in-place method because it doesn't actually return anything. Instead, what it's doing is it's going to sort new list in place, meaning that it doesn't return anything. Instead, when you call back new list again, it's now sorted in alphabetical order, A, B, C, E, X. And that's an important distinction to make because a lot of times beginners will do something like this. They'll say, oh, my sorted list is equal to new list.sort. But what's going to happen here is because new list.sort occurs in place, it doesn't actually return anything for you to assign. So when you call my sorted list, you get back nothing or none. And you can actually check the type of this, and it's going to say that it's a none type. And what none type is the type for a none object. So there's actually a special object in Python called none. Notice the capital N there. And this is just something you can use to indicate no value. And a lot of times people hold it as a placeholder, but really what it is, it's the return value of a function or a method that doesn't actually return anything. So it's a common default return value for functions that maybe search for something and may or may not find it, for example. So that's an important distinction to note here, that when you're using this .sort method, it's actually occurring in place, so you're not going to be able to reassign the result to something else. Instead, if you did want to do that, what you'd have to do is say new list .sort, and then say my sorted list is equal to new list, and then when you run that, you can have my sorted list, and using tab autocomplete there, and you'd get back your sorted list. So let's try that num list again. So right now num list is unsorted. If I call the sort method off of it, and I check num list again, now it's sorted. All right, let's also discuss the reverse method off a list. As you may have expected, it's going to reverse everything in your list. So it's just reverse, open close parentheses, run that, and it's also in place, meaning it doesn't return anything. And when you call your reverse version of your list, now you have 8, 4, 3, 2, 1. All right, that's really the basics of lists, and the most important methods to understand are the append method and the pop method, as well as the sort and reverse method. And just like strings, we're able to perform indexing and slicing. So if we come back up here, we're able to say indexing as well as slice notation like up here. So that works just like you would expect it to work as it did in strings. The only thing to note here is, unlike strings, we're able to do reassignments like we did up here with a list. Okay, that's the basics of a list. Coming up next, we're going to discuss dictionaries. I'll see you there.